Hello friends, welcome back. Hearty welcome to you. Let's look at this interesting problem and try to solve it together. The bases of a trapezium have lengths 50 and 75. Its diagonals have lengths of 35 and 120. Find the area of the trapezium ABCD. So from the diagram you can see we have been given AB and CD bases, that means they are parallel lines. In trapezium you know one pair of sides are parallel. So 50 and 75 are AB and DC respectively. We have been given AC equal to 35 and BD equal to 120. Now let's try to first understand how to find the area of this trapezium. So let us start with what we should know to find out the area of trapezium and try to proceed further to see like where we have to start with this problem. So I will say directly area of trapezium, we know that area of, this is for area, so I say area of ABCD is equal to, we know, half into sum of parallel sides, that is 50 plus 75 into height, where height is the altitude between these two parallel lines AB and CD. So we know of 50 plus 75 is okay, we don't know what is height. So we have to find out height. So to find out height, that means we have to find out, let me just write it down here, what we have to find out. We have to find out height between these two parallel lines. Let us say this is X, Y, so area of ABCD is equal to half into AB plus CD into XY. We have to find out what is height XY, which is equal to H. We have taken it as H. Now if I want to know the height, there should be some way to find out the separate heights with respect to triangle OCD and also OAB. So I should find out height H equal to H1 plus H2. To know H1, what I should know? To know H1, I need to have area of the triangle ODC. To know H1, I need, because if I know area of triangle OCD, I can find out the value of H1. Now the next thing is how to find out the area of triangle OCD. So to get the area of triangle OCD, if you want to get area of triangle OCD, I should know the sides. I should know the measures of the sides. That means I should know what is OC, I should know what is OD, and I know already CD is 50. So I should know this side's lengths. Now next point, you want to find out the sides, that means you should know, if you want to know the sides of OC and OD, we already know AC 35 and BD is 120. We have to know the ratio in which the diagonals are divided. We have to know that. If we know that ratio in which the diagonals are divided. So if you want to know the ratio in which the diagonals are divided, you should prove that they are similar triangles. So that's how you can see that where we have started and where we have went, we have to prove that similar triangles. To prove similar triangles, parallel lines will help us. So the starting point is parallel lines. Let me just summarize that, because if you are able to understand that, then this is what we are going to execute now from bottom to top. We have started how we want to solve this problem, and we got to the last step, which says I need to have parallel lines which are already available. So let me just try to summarize this. We have been given a trapezium ABCD in which AB is 75 and DC is 50. We have to find out the area of the trapezium ABCD. We know the formula of trapezium equal to half into sum of parallel sides multiplied with the altitude. Now the altitude, let us say, is xy. That's the distance between the two parallel lines AB and CD. Now you want to find out the distance xy. I have to divide that into two parts, h1 and h2. So that h1 is the altitude of triangle OCD and h2 is the altitude of triangle OAB. Now if you want to find out the h1, that means I should know area of OCD. If I want to know area of OCD, I should know the sides of OC, OD, CD, so that I can use the Heron's formula. But if you want to know the sides, you should know the ratio in which AC and BD are divided. If you want to know the ratio in which AC and BD are divided, you should prove that OCD and OAB are similar triangles. If you are able to prove that, again you need parallel lines which is already with us. So what will be our steps now? Going in this direction. We'll start from the first one. We'll start with parallel lines. Then we will prove similar triangles. Then we will divide AC into two parts such that the ratio is in 50:75. Because we know that similar triangles are triangles in which the shape is same but the size or the corresponding sides are in proportion. So we will know what is AOOC and BOOD. Once we know that, we can find out the area of the triangle OCD. Now equate that to half base into height. We know base equal to 50. Find out h1. By similar triangles you can find out h2. Then you can find out h. Then you can substitute in the formula area equal to half into sum of parallel sides into the altitude. So that is how we have started what we need to find out. We reached. So we are going to execute the steps now one by one. Okay. So that should be pretty much clear. Okay. Let's go ahead now. Let's try to apply those steps. We'll start here. The first step what we will do is, step 1 is to prove that they are similar triangles. Parallel lines already we know, it's already given to us. We have to prove now similar triangles. You can see that I will take these triangles, triangle OAB is similar to triangle OCD by AA similarity. How? Because you know that if you have parallel lines, let me just put it here. If you know that ABCD are parallel lines, then alternate interior angles are same. That means angle ACD and angle CAB are same. Similarly, we also know that angle CDB and angle angle CDO and angle ABO, they are also same. And you already know that vertically opposite angles are same. So you can see pretty much clear that they are similar triangles. How we know that? If you have pair of parallel lines and you have drawn a transversal, alternate interior angles are equal. So you know that angle CDB equal to angle, or can I say angle CDO equal to angle ABO, and also we also know that angle OAB is equal to angle OCD. How we know? I will write it down here. We know one vertically opposite angles, that's a easy one to pick. So I will say vertically opposite angles at O. That is what we know. And the second one, what we know is that if you take AB parallel to CD, AB parallel to CD, and the transversal is AC, AC transversal, that gives us angle OCD is equal to angle OAB. Or can I say angle OAB equal to angle OCD? Let me just put a line here. Okay. Now we have proven that these triangles are similar to each other. Now we have to know the ratio in which they are divided. We know that similar triangles maintain the same ratio. That means all these sides of OCD are, let us say, and the sides of OAB are in the ratio 2:3, because you can see 50:75, in lowest form it is 2:3, or I can say 1:1.5, but let's stick to 2:3 to make it easy. So 2:3 ratio, the triangle OCD and the triangle OAB are in. We know AC, we know BD. Now let's try to divide them into two parts. So what I will do now is I will try to divide this into two different triangles and try to find out the value of OD and OC. Let me just try to do it here. First I will take the triangle, let us say CD. So we have like that. This is the triangle we have. We have another triangle which is going in this direction. So that is how we have two triangles divided into. We know this is 50. We know this is 75. Let us say this is O. This is D. C here. A here. B here. Now we know AC equal to how much? 35. 35 in the ratio of 2:3. If you divide, you will have 14 here and you will have 21 here. That is nothing but 35 into 2/5 is 14, because you have to divide them in the ratio 2:3. 35 into 3/5 is 21. So we have the sides. We have the sides 14 and 21. Similarly, BD is 120. You have to divide that in the ratio 2:3. So if you do that, by same logic, you will have 48 and 72. So where are we? We have proven similar triangles. That step is over. We know the ratio in which diagonals are divided. We know the sides of the triangles. That is also is fine. Now the next step is to find out the area, and based on that find out H1. So we have to find out what is the value of H1. We have to find out what is the value of H1. We'll find out the value of H1 here, and we'll find out the value of H2. Then we will say H equal to H1 plus H2. Once we know H, we are done, because we know the formula half into 50 plus 75 into H. Okay. Now let's go ahead, and what is the next step we have to do? We have to find out the area of OCD. So for that we will use Heron's formula. We will say area of triangle OCD is equal to square root of S into S minus A into S minus B into S minus C. We'll use the Heron's formula. So you have sides 14, 48, 50. I will make it simple for you. S is nothing but A plus B plus C by 2. You can spend a couple of steps on that. I am going to do this quickly. S is A plus B plus C by 2. I will write it down for you. 48 plus 50, 98. 98 plus 14 by 2 is 56. S minus A. So S is 56. We are considering triangle OCD. S minus A is 6, S minus B is 56 minus 48 is 8, and S minus C is 56 minus 14, that is 42. Now nothing to do hard work here, because you can see this is very clearly 336 into 336. That means we know the area is 336 square units. So we found the area also, that's good. Now we have to find out H1. How to find out the H1? For H1 the formula will be half into base. What is the base here? CD into H1 is equal to 336. That is the area. We know CD is nothing but 50. We can write it there. So it will become 25 into H1 equal to 336. That will give me H1 equal to 13.44. You can check that. 25 13s are 325, 11 is left, that is nothing but 0.44. 25 into 0.44 is 11. So if you know H1, if you understand very clearly, if all the sides are in the ratio 2:3, H1 and H2 are also in the ratio 2:3. So H2 will be nothing but equal to 1.5 into 13.44. That is equal to 20.16. So we found H1. We also found H. We have to find out now. We know H is nothing but H1 plus H2. So I'll just go down here and we'll finish this. We will say here H equal to H1 plus H2, that is equal to 2.5 into 13.44, that is equal to 33.6. I was just going a little bit fast on them, but you should be okay. You can check that. Now you know H, the area of ABCD is nothing but equal to half into 50 plus 75. Somewhere we should have written it here. This is here, half into 125 into height. What is the height we have? Height is nothing but 33.6. So if you simplify that, it will be 16.8 into 125. That is 125 into 16 is 2000. 125 into 0.8 is 100. So you will have 2100 square units. So that is the area of the trapezium. This is how you can do with 10th class knowledge. In the next session what we will see is 9th class level, where you don't know the similar triangles but you know right angles. So leveraging right angles, how can we solve the same problem? Try to find out the area. But I think we are aware of Heron's formula there, because we need to have Heron's formula for both of them, because you need to get the altitude. So we will use right angles and find out the area of the trapezium in the next session. So let me just try to summarize this before I close this. I hope you are clear with that. I will just try to summarize this in 2-3 minutes. We have been given a trapezium ABCD. We have been given that the base or parallels are 50 and 75. We have been given the diagonals AC is 35 and BD is 120. We have to find out the area of trapezium ABCD. We know the formula of the trapezium ABCD is half into sum of the parallel sides or sum of bases into height or altitude or the distance between the two parallel lines AB and CD. Now we know ABCD but we don't know height. So to find out the height, what I have done, I have divided that into two parts, H1 and H2. So I should know H1 and H2. To know H1 and H2, I should know the area of the triangle. If I know the area of triangle, I will say area equal to half into 50 into H1. But I don't know the area of triangle. To know the area of triangle, I want to use Heron's formula. If I want to use Heron's formula, I should know the sides. To know the sides, I have to know the ratio in which AC and BD are divided. If you want to know the ratio in which AC and BD are divided, you should prove that these triangles are similar triangles so that you can say that the sides are in the ratio 2:3. To prove similar triangles, you need parallel lines, which is already available to you. So our execution started with our last step. So first we have know they are parallel lines. We have proven they are similar triangles by alternate interior angles are equal to one pair of parallel lines and two transversals, a similarity. So the sides are in the ratio 2:3. Leveraging that, we have divided AC BD into ratio 2:3. We got H1. First, before that, we got the area because we know the sides now. We leveraged Heron's formula. We found the area of the triangle OCD. Equating it to half into base into height, we found H1. We know the similar triangles, not only the sides but the altitudes, medians, everything is in the ratio 2:3. All the special. So we know that H1, H2 is 2:3. Therefore, I found what is H. Once I know H, I directly went and substituted area of ABCD equal to half into 125 into H. That's equal to 33.6. So you get 2100 square units. So I hope this is clear to you. Please do let me know your feedback. That's a little bit lengthy sum, but you need to think a little bit about, because that's not the general type of problem which you see in the textbook. That's a problem from art of problem solving, a challenging problem, not that challenging once you put a little bit thought on it. I'll catch you in the next session. Thanks for your time. Bye for now. Thank you.